This might look like a Boeing Autopilot, but today it's operating the fly-by-wire Airbus A320. Throughout this video, you can compare the readouts given on the Circuit Avionics Autopilot with those on the Airbus FMA, Flight Mode Annunciator, and the FCU, Flight Control Unit. Let's turn on the flight directors and get started. On the Airbus, auto thrust becomes active once we advance the throttles, at which point the AT light will illuminate. We engage managed speed mode by pushing the thrust button. We dial in QNH 1005 and our initial climb altitude, which is flight level 80. This Autopilot, by Circuit Avionics, is available to buy now. We'll advance the throttles halfway, check the engines are stabilized, then advance them to toga. The AT light illuminates. Man toga. SRS. Runway. V1. Rotate. At a height of 30 feet, runway disengages and nav takes over. Nav is the managed heading mode that will take us along our flight plan. This is mirrored on our Autopilot by the illuminated LNAV or lateral navigation button. We'll now engage Autopilot 1 and let it fly the aircraft. We pull the thrust lever back to the climb detent. It will stay in this position until just before touchdown. At this point we're in the managed altitude mode, indicated by the illuminated VNAV button, and managed heading mode, indicated by LNAV and the blank heading display. The managed speed mode is indicated by the illuminated thrust button and blank IAS-MAC display. In this mode, the aircraft will accelerate to 240 knots. We override this with selected speed on the speed button. The speed display, which was blank, now comes to life, and we dial in a selected speed of 210 knots. At this point, I tried to demonstrate vertical speed, but the aircraft was light and climbing very rapidly and had already entered altitude acquire mode, indicated by ALT* on the FMA, and Alt hold on our Autopilot. As we have climbed above transition altitude, we push the barometer knob to set standard pressure. The display goes blank to indicate standard pressure is set. The functions on the Circuit Avionics Autopilot can be customized. This profile is my chosen implementation of the Airbus Autopilot on the Boeing-style hardware, but you can quite easily go in and edit the profile if there's something you want to change. The software is called MobiFlight. It's free and has a great online community. We want to leave our flight plan, so we engage heading select and dial in a turn to the right. The LNAV light is extinguished. Airbus aircraft can increment the altitude in 1,000 or 100-foot increments by use of a selector. On our Autopilot, we can toggle between the two modes by pushing the altitude knob. Let's climb with vertical speed mode. Another Airbus feature is the heading track and vertical speed flight path angle button. As it relates to both heading and vertical speed modes, pushing either of those knobs on your Autopilot will push the button on the aircraft. When we're in track flight path angle mode, our vertical speed window changes to show the aircraft's flight path angle in degrees. and the aircraft's track along the ground is also shown. The track differs from the heading because we have a crosswind coming from the south. Our EFIS map controls allow us to change both the mode and range of the map display. There is also an unassigned push function. You can assign this to any function on the aircraft. We can use our level change button much as we would on a Boeing aircraft. In Airbus parlance, this is open climb, or, in our case, open descent. In this mode, flight plan altitude constraints are disregarded. I've been focused on showing off the interaction between the aircraft and the autopilot, rather than proper procedure, so we're going to come in too high and too fast for this approach. We've already engaged full lock, and as we're below transition altitude, we push the baro knob again to get back onto local pressure. Here you see the unit switch in operation. On modern Airbus such as the A320, minimums and course are set on the MCDU, so they do not function on our autopilot. You can reassign the unused controls and display to something else if you prefer. The autopilot is made of steel and weighs 1.2 kilos. There's an industrial-grade finish in Boeing grey and laser-engraved text. Sitting on your desk, the unit reclines back a few degrees for the optimal viewing angle. We push approach to begin descending with the ILS. We push the thrust button to go into managed speed mode. The aircraft will attempt to slow to green dot speed as we extend the flaps.
2,500.
The speed brakes and landing gear will hopefully slow us in time. second autopilot is engaged for redundancy. Airspeed continues to reduce.
1,000.
Autopilot disconnect.
$400. 100 above. 100 above. 100 above. Minimum. $50, $40, $30, $20. Retard. 5.
Hopefully you're a better pilot than I am. Circuit Avionics was created to bring affordable, quality, pilot configurable products to the flight sim community. I hope you enjoyed this video. If you don't already have an autopilot, I hope you will go and buy one, because it's as worthy an addition to your simulator as a joystick or yoke. If you're wondering about the Phoenix A320, at the time of recording, Phoenix just announced they are opening up their aircraft to hardware developers, and I am very much looking forward to supporting the Phoenix A320 as soon as this work is completed. Thanks for watching.